Welcome to The Explainer. Today, we're diving into what many are calling the next huge step in artificial intelligence, something called AI agents.
So, for a while now, we've all gotten pretty used to AI that can chat with us, right? It can write stuff, come up with ideas, but that's really just the tip of the iceberg. The real game changer, the next big leap, is AI that doesn't just talk, it does. It actually takes action for us. And right there, that's the fundamental shift we're talking about. Think about a normal chatbot. It's reactive. You ask a question, it gives you an answer. It's basically a conversational partner. But an AI agent? Totally different. It's proactive. You give it a goal, a big, high-level goal, and it just goes. It figures out the steps, makes its own decisions, and works to get it done, all on its own.
Okay, so let's get into it. What exactly makes an AI an agent? What's the magic happening under the hood here? So here's the formal definition. But honestly, the best way to think about it is like a superpowered project manager. It takes that big, large language model, the LLM, and uses it not just to chat, but to reason and to plan. You give it a big goal, and it breaks it all down into smaller tasks, and then just executes them. You don't have to hold its hand for every single step.
So what's in the secret sauce? What gives these agents all this power? Well, it really boils down to two key things: giving the AI a memory and giving it a set of hands to actually interact with the world. Let's open up that toolkit.
First up, memory. You know how a language model's knowledge is basically frozen in time, right? It only knows what it was trained on. That's a huge problem. Well, RAG, that's Retrieval Augmented Generation, is the fix. It's like giving the agent a library card to go look things up in real time, searching external knowledge bases for the latest info before it gives you an answer. And this is how it works. It's actually pretty clever. You ask a question. Before the AI even tries to answer, the system goes and fetches a bunch of relevant documents or facts. Then it bundles your question and those facts together and hands it all to the AI. This is huge because it means the final answer is grounded in actual, current data, not just some half-remembered fact from its training.
Okay, so memory is one piece of the puzzle, but it's not enough, right? The agent has to be able to do stuff, and that's where something called function calling comes into play. This is what gives the agent its digital hands.
And the process here is just brilliant. You ask a simple question in plain English, like, what's the weather in London? The LLM is smart enough to realize, hey, I can't answer that myself. I need a tool. So it translates your question into a computer command, an API call. It calls the weather service, gets the live data back, and then translates that technical data back into a simple, friendly answer for you. This is the magic that lets an agent book a flight, or add something to your calendar, or search the web for you.
So you've got your key instruments, right? You've got memory with RAG, you've got action with function calling, and you've got the LLM's reasoning. But to make beautiful music, you need a conductor to lead this whole AI orchestra, and that's exactly the job of agentic frameworks.
And wow, take a look at this. It really shows you just how many different pieces have to come together to build a real production-ready agent. You're juggling memory, tools, different protocols, ways to evaluate if it's even working. It's a lot. And managing all that complexity is precisely why these frameworks are so critical.
Right now, two of the biggest names you'll hear are Llama Index and LangChain. Think of Llama Index as the specialist for agents that have to wade through massive amounts of data. LangChain is more like a general-purpose Swiss Army knife. It's super modular and well-known for its LangGraph system, which lets you build really complex step-by-step agent logic.
Okay, so we've got the tools, we've got the frameworks to manage them. Let's get to the fun part. What can these autonomous agents actually build and do in the real world?
And the thing is, this isn't science fiction. These applications are already here, and they are seriously powerful. I mean, imagine a personal assistant that doesn't just ping you about a meeting. It books your flight, reserves the room, and even puts together a summary briefing for you based on your recent emails. Or, get this, a legal agent that can read a 1,000-page contract, find the exact clause you need, and automatically flag any weird inconsistencies and draft an email to the lawyers about it. That's the kind of autonomy we're talking about.
But, and this is a really important but, giving an AI this much power and freedom to act on its own opens up a whole new can of worms when it comes to security. We're talking about risks we've never really had to deal with before.
And it's not just me saying this. Industry experts are all pointing to the same thing. This whole agentic transformation isn't just about cool new features. It forces us to completely rethink how we approach security from the ground up.
The real challenge here is the complexity, because these agents can string together long chains of actions all by themselves. A single tiny vulnerability could be exploited in some really unexpected, cascading ways. It makes getting the security right from the very beginning absolutely crucial.
In fact, it's such a big deal that a huge group of experts, we're talking people from more than 20 top organizations, got together and created a top 10 list of security risks that are unique to these AI agents. Let's take a look at a few of the big ones.
First up, there's what's called agent authorization and control hijacking. Basically, this is where a bad actor tricks an agent into using its powers for evil. And what makes this so scary is that one little trick can kick off a whole chain of automated actions, like the agent grabbing private data and then emailing it to the attacker, all on its own.
Then you've got goal and instruction manipulation. This is where an attacker subtly twists the agent's main objective. Imagine a research agent designed to summarize news. An attacker could quietly change its goal to find and spread misinformation. The agent wouldn't even know it's been compromised. It would just happily and autonomously work towards its new malicious purpose.
In this last one, memory and context manipulation is honestly a bit chilling. This is where an attacker poisons the agent's memory. They feed it bad information through its RAG system, its connection to the outside world. And then the agent starts making all its autonomous decisions based on a completely fake reality that the attacker built for it.
So all of this really leads to the biggest question we face as we step into this new AI era. As we start to hand off more and more control to these autonomous systems, how do we build the guardrails? How do we make absolutely sure that they stay safe, secure, and, most importantly, aligned with what we actually want them to do? That is the massive challenge ahead of us.